Okay, so our first question asks, convert the point in xy 3.0, comma 4.0 into r theta. So how do we do that? Well, our pretty much way of doing that is we find the r by doing the square root of the squares of x and y. So it's square root 3.0 squared plus 4.0 squared. You know, Pythagorean theorem, and that is going to equal our r. So we can set that up and we can plug that into our calculators. So we can do root 3.0 squared plus 4.0 squared and enter, which gives us 5. So our r is going to be 5. And then how do we find theta? Well, our equation is pretty much, it's the inverse tangent of our y over x. So our y in this case is 4.0, so it's inverse tan y4 over x, which is 3. So that's going to give us, just plug that right into the calculator, inverse tan, which is second tan, 4.0 over 3.0. And that gives us 53, because sig figs 53. So our theta is 53 degrees. So convert the point xy 3.0 to comma 4.0 into our theta, and it gives us 5 comma 53 degrees. Okay, so our next question asks, a vector has components xy equals -5 comma 2, and we have to find our theta. So our first step is to find our r, which is pretty simple. It's just Pythagorean theorem. So we plug that in. It's 5 squared plus 2 squared, and we get 5.4. So our r is 5.4. And then we have to find our theta. Now, in order to find theta, it's pretty much the same thing. It's inverse tan of our y, which is 2.0, over our x, -5.0. And let's plug this into our calculator. Inverse tan 2 over -5. And we get -21, or 2 sig figs, so 22. And we could say that's our theta, but we have to think about this. So let's graph this real quick, because we have a negative theta. So what would this look like? It would be left, let's just say this is -5, this is 1, 2 on our Cartesian plane. So left 5, because it's left, so -5 is here and 2 is here. So our vector would look like this. And so that would mean, starting here, it would be a big angle. What is that angle? Well, to find that out, we would have to do 180 plus -22, because that's what theta is. And so 180 minus 22 gives us 158. And that is actually our theta, 158. Because our theta is negative and it's going in the opposite direction, it's actually going. So that's where you use 180 and subtract it. Okay, our next question asks, given vector r 5.74, comma -2.18, comma 6.55 meters, find the unit vector. So what is a unit vector? It looks like this equation. R is it's r, which is direction, over r's magnitude. So it looks like a wonky equation, but it's just how it is. So how do we find magnitude? Well, that's our first step. So it would be, again, it's root and then all the squares to find the magnitude. So it's root 5.74 squared plus -2.18 squared. Let's extend that, plus 6.55 squared. So that is our magnitude. So let's just plug that in the calculator. 5.74 squared plus 2.18 squared plus 6.55 squared. That gives us 8.4 8.98 because sig figs. And then from there, we have our magnitude. Now we have our r equals, which is this given vector right here. So this is our x, this is our y, this is our z. So in order to find this unit vector, we just do this divided by our magnitude. So our x divided by magnitude, y divided by magnitude, z divided by magnitude. So let's just do that. So our x is going to be 5.74 over 8.98. Then our y is going to be negative 2.18 over 8.98. And our z will be, like you guessed, 6.55 over 8.98. So next step is to plug all of these into the calculator. 5.74 divided by 8.98. We get 0.639. Now to find our y, negative 2.18 divided by 8.98, we get negative 0.243. And for our z, 6.55 divided by 8.98, we get 0.729. Now, how do we find what are the unit vector's coordinates, like x, y, z? Well, simple. We already found it. So our unit vector is, our x is 0.639, our y is negative 0.243, and our z is 0.729. And that is how you find the unit vector. Okay, our last problem is superposition. So the question is, find the superposition of these two vectors. So this is pretty much net force. So as we can see, F1, the vector, is actually already in Cartesian plane, so coordinates, so we can actually just leave that, but our F2 is not, so it's in r theta. And so we have to convert this to xy, and then we can add them together. So how do we do that? Well, it's r cosine theta and r sine theta. So this finds x, this finds y. So let's plug those in. So 8.33 cosine 67 degrees, and then 8.33 sine 67. Sorry, and then so yeah, we can solve for those. So 8.33 cosine, and we get 3.25, and then 8.33 sine, and we get 7.67. And then our next step is to change this to 3.25 comma 7. And then now, since we have those, we can just add them up and find our superposition. So we can do 4.36 plus 3.25, and then it'll be negative 2.93 plus 7. Now let's add these up. 4.36 plus 3.25, we get 7.61, and then comma negative 2.93 plus 7, and we get 4.74. And don't forget, actually we'll go down here, our units, so it's 7.61 newtons, comma 4.74 newtons. And there is our net force / superposition.